So we can now write down y is equal to FKL. Okay? As I mentioned before, in microeconomics, usually the next step we're going to say is that y is equal to FL. Okay? Because every economy has a given amount of capital. But this time is different because our focus is on capital. And so what we're going to do, we're going to have y divided by L, and then this is going to be L, FK, sorry. Okay, so if you want to do this, it really depends on the function you have, okay? And as I mentioned before, y divided by L, we're going to have per capita production, okay? Per capita production. So it is production or quantity, okay, per labor, okay? And then this is going to be F, okay, K divided by L, and then here equals to 1. As I say, it is not every function, okay, has this kind of property. It depends on, for example, it is monotonic increasing or monotonic decreasing, okay? So if the function is something like this or something like this, okay, it's going up or it's going down. Or otherwise, if it's different kind of situation, different kind of function, you cannot do this. And since this is 1, right? L, okay, the left-hand side, okay, from y divided by L, the left-hand side becomes per capita. Per capita means per person, okay, per person production. And now we turn this to F, K, okay? Questions? So this now becomes per person production, and it is a function of per person capital, okay? Per person production, per person capital. And what we have, the equilibrium is still this. I is equal to S. Investment equals saving. Okay, investment equals saving. And so, what else? We're gonna give you a diagram. The diagram is like this. So you have K, and then you have Y. And remember that what is K? K is equal to big K divided by L. It means per person capital, okay, per person capital. And this is the production function. So it is Fk, okay? Okay, so, and then what is this? Y, that's your income, right? Your income can be used for consumption and then for saving, okay? We can do the same thing. So Y, okay, if we divide it by L, and here you divide it by L, and here again, it divided by L. Okay, so what do you have? You have Y is equal to little c plus little s. Okay? Okay, so if this is like this is S times Fk, right? So here it is consumption per person, and here is saving per person. Okay, So it is a different way to describe your income, okay? And how is the production working? It's like this, okay? You have F little k that is given the per person capital level. This is your income, okay? And here is the saving, consumption, saving, okay? Okay, so this is the equilibrium, okay? Y equals S is the equilibrium. And we are talking about a new concept called steady state. Steady state. What is steady state? Because in each economy, we use machine. A machine will have depreciation. And suppose every year you're going to make up for the depreciation. It means what? It means you can have a steady state. It means that. So let us say the wear and tear, okay, is 1 million per year. And every year you invest 1 million to make up for the loss in your capital. What does that mean? That means this year will be the same as last year, okay? So basically, what we have is we have an investment, okay, per person investment, okay, per person investment, and that is equal to delta K. What is this? Depreciation rate. This is depreciation rate, okay? So what does that mean? That means if every year our investment can make up for the loss in equipment, okay, in machinery, what does that mean? We will be in the same situation, steady state. And so, what does that tell you? Suppose you have the investment, okay, is equals saving, and then equals the depreciation there. So this is the depreciation rate, okay? This one tells you it is in steady state. Because your investment is able to make up for the loss in equipment, for the loss in depreciation. So this is called steady state. And what is this? This is investment equals saving, right? Investment equals saving. So what is that? That is equilibrium. Okay, that is equilibrium. So this is equilibrium, and this is steady state, right? This one is this one, right? So that means this is steady state equilibrium. Okay, steady state equilibrium. Okay? Okay, how does it work? Okay, let us see what's going on here. So we have, okay, remember the horizontal axis is little k, okay, capital per person. And here is little y, production per person or income per person. And then you have this here, okay, S times FLK, okay? And then what it is? This is delta K. So what is this? This is depreciation. Okay, this is depreciation. And then from there, what you get? K star. This is the optimal amount of capital per person. And this is, okay, the production, sorry. The production level per person or income per person. And this is the equilibrium. Why? Okay, let's try here. Suppose, okay, the capital is higher here. Okay, suppose you have K1 here. So if you have K1 here, what is going to happen? Okay, so here is the depreciation, right? Remember, this is depreciation, and this is the amount of saving. And as we say, saving is equal to investment. So what does that mean? This is your saving, this is your investment, but is it able to make up for the loss in depreciation? The answer is no, because the depreciation is higher, right? And so, because the depreciation is higher, so what is going to happen? The production level will go down to here, right? And at this point, okay, what happened? Depreciation is still higher than the saving, okay? Depreciation is still higher than the saving. It means that your investment is not enough to compensate for the loss in depreciation. So you will get here. So this is the equilibrium. Okay? So what about if it is down here? So let us say K2 is here. Okay? Okay, so what happened? Depreciation is here, right? Okay, depreciation is here. Okay? But what about here? This is your saving. Okay, this is your saving. So this is your saving, this is your investment. So every period, okay, you can accumulate, you get more capital, okay? You get more capital. When you get more capital, you get more production, you get higher income. So it's gonna be something like here, okay? And what happened? At this point, saving is here, right? But depreciation is here. So you can continue to accumulate more capital per person. So your income gonna go up, your production gonna go up. And so to here, you know, because you have more investment, more equipment, of course you're gonna get higher productivity, and then you're gonna get more income. So again, right? And again. So here, it is the equilibrium. When your per person capital is larger than the equilibrium, what does that mean? That means actually you don't have enough saving to compensate for the loss in depreciation. And because of that, you have more capital gone and you don't have enough investment to compensate for the loss, so you will have loss in productivity. So it is going down, going down, going down to this point. But when the capital level, okay, is below this optimal capital amount, what does that mean? That means actually your saving is greater than depreciation. It means each period you can accumulate more machine. If you have more machine, you have more productivity, you get more income, and you get more production. Okay? So this is the this is the equilibrium that you're going to get. Okay, so this is indeed the equilibrium point, because above this one you have higher depreciation, below this one you have higher investment level. So here, when it's down here, you can accumulate more capital, and here you have lost much more capital, and so the productivity going down, production going down. Okay, questions? Okay, so let's move on. Okay. Questions? Let me draw a new diagram. So K here, Y here. Okay. The question here, if you have higher saving rate, okay, so let us say you have a higher saving rate, what is going to happen to this economy? Okay? So, we say higher saving rate so let us say it is something like this. S2 times FLK. Okay? So as a matter of fact, what you get? This is, let us say, K1, right? And this one, K2. Okay. So can anyone tell me what's going on here? Okay, 반수연. So, saving rate go up, okay? Saving rate go up. What about output level? Output level goes up or down? Okay, savings goes up, right? What about output level? Go up. What about capital level? Go up. So, you see, it's different from Keynes. Keynes say if you're gonna have higher income, okay, more production, what would you need? The multiplier, right? Expenditure multiplier, okay, expenditure, and this is equal to MPS, okay, 1 over MPS. So if you look at Keynes, what's going on here? If you really want to have higher growth, higher production, right, what would you need? You need to consume, right? If you save a lot, right? MPS, if MPS going up, okay? If MPS going up, the whole thing actually is going down, right? What about Soto's model? For Soto's model, what you get? If you have higher saving rate, it means per person capital gonna go up. Okay, per person capital gonna go up. Also means, the more capital you have, it means you have more wealth, right? You have more assets. So basically, it means you become wealthier, right? And so in this case, saving rate go up. Okay, saving rate go up. What happened? Personal production level goes up, and personal capital level go up. And if this goes up, right, it means the big Y, that is total production, will go up too, right? And total capital level will also go up. Okay? Questions? So it's different. And you're gonna ask me, who is right? Okay? So Chen Youxi, Keynes is right or Soto is right? Or they are both right? Anyway, she just said, who is right? Soto is right or Keynes is right? Both? How come? How can they both be right? Exactly. There are two different models, right? As I say, Soto model starts from production. Okay, Soto model starts from production. And Kent's model starts from demand. Okay? It talks about aggregate expenditure, but he doesn't mention anything about production. And Soto mentioned production level, right? Production function. It doesn't say anything about demand. Okay? So they are both right. But if you're gonna say if we're really gonna test it, okay, which one is right? As I had already told you last year, right? Last semester. You know, generally it is very hard to see the multiply effect. It's hard to see. And the reason is quite simple, right? Because Kent's model doesn't discuss price level, right? It doesn't discuss interest rate, okay? So after we, discuss aggregate demand, aggregate supply model, and also ICOA model, you know that, right? Because if you consume too much, what happens? You will have crowding out effect. Okay, government expenditure going up, and if you consume too much, you have too much demand. Price level will go up, right? So the other thing is crowding out effect. If government expenditure increase too much, they borrow too much money, interest rate will go up. Okay? Okay, questions? Okay, so let's move on to the next part. So then, okay, here. Let me get this. So this is saving rate, okay? This is saving rate. And then this is depreciation rate, delta 1K. And then this is delta 2K. Okay, if depreciation rate go up, okay, if depreciation rate goes up, what does that mean? That means K will go down, okay, per person capital will go down, and per person production will go down. And basically that also means K will go down and Y will go down too. Because if you have higher depreciation rate, means the capital, the wear and tear of capital, machines, equipment, all these things, is gonna be much heavier. And so if you want to keep the economy going at the same rate, okay, it's much more difficult because you have to have a higher saving to make up for the loss in depreciation. And so because of that, okay, if depreciation rate goes up, okay, what happened? Per person, capital will go down. Per person, production will go down. So per person, income will go down. And the same thing for total capital and total production. So it means that the whole economy is getting poorer. Okay, everyone is worse off. They don't have as much money as before if you have higher depreciation rate. Okay. Okay. Let's get to another one. Okay, population growth. Population growth. Okay, generally you're gonna believe more people better, right? Because you get more people, and then labor market is booming. You get more people to work. It should be something nice, okay? But it turns out that it's not quite the case. So supposedly you get more people. What happened? Because all these people also need machine, right? Also need capital. And if you don't have more savings, then what happened? All these guys don't have as much equipment, as much machinery as they should have. So it means productivity will go down. So let us say this is the case, okay? Little k, little y, okay? And here it is SFLK. And here you have delta little k, that's the depreciation. So if we consider population growth, and that population growth is equal to n, what does that mean? That means in addition to the depreciation, you also need to have someone to share with the existing capital. And so what does that mean? That means each person gets a little bit less. And so it's the same thing as higher depreciation rate. So let us say now if we consider the population growth, so you have n plus delta times little k. So what happened? Okay, if you consider, okay, population growth, okay, growth rate goes up. What happened? Little k goes down, and also little y goes down. Okay, but what about big K and big Y? Because we know capital per person, okay, will go down, production per person will go down. But what about the total amount of capital, total amount of production? Because in this case, we are not sure. Why? Because you have population going up. If population going up more than this going down, then the big K will go up, big Y will go up. But we don't know. So because of that, this one is not sure. Okay, it depends on, again, elasticity. Okay, if the elasticity is higher, then it's going to go down. If the elasticity is lower, it's going to go up. Okay? Okay, sounds good. Let's take a break.